there is, so you can't miss that. Thank you, Jonathan. Over to you, Vic.
Okay, well, thank you, Rick. And I'm really delighted to be introducing Mark. A lot of us know Mark Peason, but for example, from the Shack Tour in the last meeting. But probably most of us don't know about his many accomplishments and his many skills, his multiplicity of skills, and how fortunate we are to have a person of this caliber in our club. For example, Mark was inducted into the CQ Magazine Amateur Radio Hall of Fame in 2018. That's a pretty great thing to have in our club. A member who's been inducted there. So Mark grew up in Chicago and went to the University of Pennsylvania, where he did a master's in engineering and studied technology management at the Wharton School of Business, where he's a graduate. And he began his career at Bell Labs and then quickly moved to Motorola. And at Motorola, he worked on a lot of the, he did a lot of protocols and technology innovation in a lot of the fundamental technologies of cellular telephony and ICT in general. For example, he's worked on GSM, the Global System for Mobile Communications. He's worked on Universal Mobile Telecommunications System, UMTS, which is kind of what CDMA evolved into for global communication. He's worked on high-speed packet access. He's worked on LTE for 4G, which you see in the upper corner of your phone usually when you wind up doing LTE. And he became involved in proposing aspects of these as global standards to ensure interoperability at things like the European, at ETSI, the European Telecommunications Standards. Oh, I'm flaking out on the I. Mark, help me out. What's the I in ETSI?
Oh, Institute.
Institute, thank you. Okay, and I looked him up on the US Patent Office website, just pulled down the inventor like item in the menu, pull down menu for searching and put in Mark Peason, 104 patents in all of these areas, with titles such as method and apparatus for simultaneous circuit switching, voice and GPRS data interchange, communications controller and methodology for managing the traffic flow of a communications connected during cell reselection, multiband antenna and methodology for radio communications device. You know, those are just some of the titles. So it's kind of a broad range of topics. And this has resulted in him being installed as a distinguished innovator at Motorola. He came to Waterloo to be the senior vice president of research and advanced technology at BlackBerry. He built the research and advanced tech team, and in fact, a lot of the laboratories and ways that team could succeed within BlackBerry. He drove a lot of patent activities. He did a lot of consulting to the CEOs. And I dare say he probably advised them not only on technology, but also on some business considerations and intellectual property considerations. Since then, he's become involved with the two universities, with UW's Institute for Quantum Computing, where he's been a board member and has had a number of roles, and also Laurier School of Business and Economics. through that activity, he became this chief operating officer of Icera Corporation, where he focuses with the team on ICT system and network security. And he's chaired the ETSI effort in quantum safe cryptography standardization in France, which took him out of the country for quite a while on an almost full-time basis and often part-time basis. He's trying to be semi-retired now, I think, which is why we're seeing more of him and why he's on the air a little bit more. But he's still the CEO of Approach Infinity, and there he gets involved with advising on technology and management for wireless and other new technologies or emerging technologies, not only for startups, but for sort of the ecosystem around them, like the legal people and the finance and the regulatory issues and the marketing and standardization aspects of those companies. So he's invested in startups locally and elsewhere, benefiting progress here and elsewhere. John Klassen and I sat down with him after a recent antenna event in his backyard. And he was telling us about being a radio announcer when he was in school, not only being the engineer at the radio station, but also announcing. So, and you can tell from his voice, he's got a great radio voice. Not that you don't have a face for television too. So I'd like to commend you to Mark, to his excellent voice and encyclopedia knowledge of radio and the evolution of amateur radio. Thanks, Mark. Over to you.
Oh, thank you, Vic. I really appreciate the intro, and I guess I'm just a boring engineer, as I kind of and boring business guy, you know. But I'm going to have to share my screen here, and what I will do, the little history of this talk. Originally, I gave this talk 9 years ago, where I constructed the original version of this talk 9 years ago for the IEEE International Microwave Symposium that was held in Canada. It was in Montreal. And I had to look this up because I don't remember 9 years ago, but there was over 7,400 people at the event. And there were a few hundred at the ham radio event, which surprised me. One of my employees actually talked me into giving the talk. Okay, can you see my screen now? You can see it? Is it in presentation mode? Is it okay? Okay, cool. So this is a very interesting thing for me to put together. I'm going to concentrate more. Okay, so 45 minutes, that takes us to 10 after 9, right? So exactly 45 minutes. I'm going to concentrate more on the early stuff because there's a lot of things that I learned in putting this together that that really affect us today. Why we do the things we do today are a lot of times are dependent on the things that happened in the very beginning. So we'll look at the origins of amateur radio. And so first of all, if you were a researcher working at a university back in the 1850s, UW wasn't around then, but my university was, University of Pennsylvania was, and Cambridge, et cetera. And at Cambridge, you had James Clerk Maxwell, who came up with a new model for examining both electrical and magnetic phenomena in around 1861. So if you were a researcher back in those days, you'd be studying things like electric motors and generators. And telegraphy was there. You had wireline telegraph. You would look at electromagnets and things. And so Maxwell came up with the infamous equations on the right side. That what they say is that mathematics is the is the science of studying relationships. So you can figure out things about how multiple things are related by mathematical operations. And basically, what he proposes that a varying electrical field gives rise to a varying magnetic field, and vice versa. So that's really all they say. But you had to wait 30 years. We had to wait until 1891 when Hertz and both Popov in Russia, so Hertz was in Germany and Popov was in Russia, and actually built proofs of concept. So it took a while before anybody actually did this to demonstrate it. And you'll see the little schematic that they have on the right side where it has this induction coil, there's a battery and there's an interrupter. And now what he's using here is a spark gap, a high voltage spark, to excite a tuned circuit. Now you're wondering, okay, a tuned circuit's a coil and capacitor. So where's the capacitor? But if you look at that little table thing on the right side, it's maybe a little more obvious that the stray capacitance between those two capacity hats that are at the ends of the antenna are the capacitor. And this thing would put out a signal that you could detect like a meter away, which of course people, in seeing this demonstration, of course, promptly responded enthusiastically with the idea that, this is cool, but it's useless, and it turns out that they were operating at a frequency about 100 megahertz, which, you would not really get out of your backyard with 100 megahertz of spark back in those days. But a year later, you had a guy who was much smarter than I am, start filing patents on this thing, Nikola Tesla. Now, to give you an idea of this guy's capacity as an engineer and researcher, it was amazing. He Litz wire, rotary spark gaps. He built receivers. He built receivers that had interference rejecting tuned circuits. He had series tuned circuits that would shunt the interference to ground, and parallel tuned circuits that would peak up the desired signal. But you got to remember, we have test equipment. He had no test equipment. In 1892, in the 1890s, this guy was just living on intuition and math. And he did all this interesting stuff. So Tesla and others got involved with wireless. And in 1896, you had the first practical wireless system put together by Marconi. And when he saw the experiments of Hertz and Popov, he homed in on the market segment. So he was a business guy too. He segmented his market up, and he homed in on the market segment of maritime communication. And he had a lot of trouble with adoption. Shipping company owners and shareholders didn't really see the need for it. They were like, well, why would I want to talk to a ship at sea? It's at sea. I don't need to talk to them. But the notion of operations research was not there. It was not like, oh, you left this port and you're empty, but you're close to another port. You could pick some things up and bring them back to Europe or something. That wasn't in their mind space at the time. But he leaned on this emergency communication stuff, and he sold that schematic that you see on the right. It's not a schematic as you would know it, but or we would know it. But this is the actual schematic of the day, drawn for the 5 kilowatt system that was used on the Titanic. And you could see the standard, there was no standardization for schematic symbols back then. They looked like little pictures of things. And you can see that little thing that looks like a motor, and they call it a converter because it spun this spark gap thing that whizzes around and modulates the spark. But that was the actual thing on the Titanic at the time. And of course, in 1898, the U.S. established their first coastal station for the military, and obviously that's, that's going to happen. In 1899, this is a really interesting time period. The first commercial use of wireless was actually done in 1899. And to understand why this was so cool in 1899, you got to understand the culture. There was no radio, there was no television. People got their news in big cities like New York and London and Paris and so on and so forth from newspapers. And there were several newspapers every day. There was a morning edition, a noon edition, there was an afternoon edition, an evening edition. There were extra editions in case something was happening. You'd have an extra edition. And so normally they would have this race for 2 weeks, and there may be a couple of periods of reporting over this 2-week period by people who could see the position of the boats, from which they could have a telegram sent by wireline to the newspaper, and they could report the positions of some of the boats. But having wireless aboard the ships, some of the ships, they could report the positions every day, and that was like revolutionary. I mean, radio was a cool thing back then in 1899. Also in 1899, DX was the order of the day, anything over 10 miles. Now, why do we not use kilometers? Because the world was still using a lot of English system things back then. But between 1899 and 1912, anything over 10 miles was considered DX. And of course, in 1899, also Marconi sent a signal over the English Channel, 32 miles. And in 1901, he built this gigantic thing. You see this on the right upper hand right corner, the gigantic base station of sorts, where he had a transatlantic contact between, it was actually between Ireland and Canada. And in 1902, Oliver Heaviside predicted that there was some kind of a conducting layer in the upper atmosphere, because he observed that radio waves tended to follow the Earth's curvature to some degree, some days more than others. And of course, in 1923, this Heaviside layer was proven once the researchers started building things that could be used as ionospheric sounders, and they would send these signals up. They had oscilloscopes by then, so they could accurately, well, more or less accurately, measure the return time of the signals. Now, you'll see also in 1905, of course, the regulators started getting involved, because it became more or less a free-for-all. And now there's a couple of interesting stories here. The ITU is the forerunner. The forerunner of the ITU was called the Union. It was called the Telegraph Union, and it was founded in 1865. And why do I know that? I've been a delegate to the ITU and the UN a number of times. I'm actually a member of the International Amateur Radio Club in Geneva, Switzerland, at the ITU. And in 2005, the head of the Ham Club there and 4U1 ITU station, that's Attila Mattis, OM1AM, he gave me a copy, this replica copy of the Convention de la Télégraphie. And so the Convention was made in 1905 by participating union member countries. And I started poking through it because, being in ITU meetings is not as exciting. I mean, it's boring and formal. I mean, it's just, but it's mostly like a bunch of hams kind of go upstairs and we get on the air as long as we don't turn that amplifier on during the day when there's the girl in the office next door, because she'll complain. But I started leafing through this thing, and this Article 5 I found, it's written in specification language, just like today, except it was written over 100 years ago. And I noticed there's 2 provisions in this thing, and I can paraphrase these things to you. The first one says basically that the exchange of useless an unnecessary signals is prohibited amongst the stations targeted in Article 1. And I looked that up. Article 1, they're talking ship-to-shore stations. So, okay, useless information is prohibited. What they mean by that is, okay, we have precious limited supply of spectrum. Don't waste it with stuff that doesn't matter. There's people paying for this, you know. The second sentence, the second provision, it says it's okay to do trials and tests as long as you don't interfere with the traffic of other stations. I started thinking about this, and, you know, in other words, interference and capacity. Now, in my career, I've made a lot of investments for companies and myself on things like high order modulation techniques, things that increase system capacity, modulation encoding schemes. There was interference cancellation. I had a whole huge bunch of projects on that. And I started thinking about this, and, you know, these two provisions could have been written yesterday or tomorrow. The problems are still there. It's just that these basic physical limits still exist. It's just that we have gotten better over the past 120 years or so at mitigating these things. But still, you know, if you talk to executives at any of the wireless operating companies like Vodafone or Rogers or Orange or whomever, you know, they're going to say, "Oh man, spectrum is expensive and all this kind of stuff. And what can you guys do to help us with capacity?" So interesting couple of forces here, and they're still valuable today. And I still have this little thing. It looks like a little leather bound thing, but anyway, the decisions when you were in the ITU as a delegate, all the decisions amongst the countries are treaty binding. So the prime minister, the presidents of all these 193 member countries of the UN have to sign off on these things. So it's a very, very important effort. So the first wireless speech actually was done, well, first of all, it was done by a Canadian, the guy Alexander Fessenden. But second of all, the really weird thing about it is that he voice modulated this 2 kilowatt, 100 kilohertz alternator that produced a spark. And the spark was modulated by an alcohol flame. And it's something, I looked this thing up, and alcohol flame has a certain property. You can't do it with just any flame, but you have an alcohol flame running through this spark, and you have this tube you talk into. And the sound pressure modulated this flame. And if you go on the web and you look up Fessenden and audio and spark and all that kind of stuff, you could find the recordings of some of his early recordings of the early voice modulated spark, and it sounds horrendous, but it worked. Also in 1906, the Berlin International Wireless Telegraph Convention defined the call letters and operating procedures for wireless stations. They had to do that because otherwise it would get out of control. And they standardized the name radio, which was like a cool word back then, almost 100 some odd years ago. Also, again in 1906, Lee DeForest, who was an American, invented the triode, the Audion tube. This thing could both rectify and amplify, and you could get it to oscillate. You could feed part of the output back into the input, and now you had a way of exciting a tuned circuit without having to excite it with pulses that are really broadband and messy and dirty and not very efficient using a spark. So that, of course, spelled the end of spark at some point. Now, ham radio itself actually started back around 1908. It started before that a little bit. I mean, experimenters, researchers and experimenters grabbed this idea because it was pretty slick back then. Hugo Gernsback started his publishing company. I still remember he was in business, or his company was still in business rather, in the 70s. And Modern Electrics helped to popularize ham radio. In 1909, there was the first ham club. Now, young hams back in those days built receivers with whatever parts they could, including some earphone elements that they ripped off from telephone booths. That stuff was still going on in the 60s and 70s, by the way. Another interesting story, Don Wallace, he was an early ham back in the day, and he took a spark coil from a car and built a mini spark transmitter. So there was like an interest in doing this. In 1909, the call book was issued. This was called the Wireless Blue Book. And in 1910, the first cat's whisker detector was invented by B.F. Meissner. I think that's how you say it. He was American, and his patent was sold for $200 US. Now, of course, being an inventor myself, I wanted to understand, is this a good deal, a licensing deal or not? So, of course, I looked up the inflation calculator for US dollars to today versus 1910. And so 1910, $200 in 1910 is worth about 5,600 US dollars today. So any way you cut it, it was a really not a good deal as a licensing deal for patents. Now from now on, if you look at the right side of all the slides, you're going to see these tell a whole parallel story here with this. These are the homebrew things that made ham stations back in the day. And you see they're really, really crude. You had coil forms that were wood, made out of wood, the cardboard, paper. You've got a lot of just really, really crude stuff, even homemade switches. The stuff is just really, really not like, it's not like an Elecraft K4, for example, or a Flex or something that you might find in one of your shacks. In 1912, formal regulations came by most of the countries, Canada, the US, European countries. They started with these so-called Radio Communications Acts. Canada had one that set forth the licensing for hams. And back in 1912, they were allocated frequency bands of 200 meters and down because this scarce spectrum below 200 meters was very, very expensive. But they figured that, well, anything above 1.5 megahertz was useless. Just give it to the hams. Maybe they can use it for something. And they figured out in 1913, they were using Audion tubes in their receivers, which were much more sensitive than coherers and the kind of junky detectors of the day. So they were working 250 miles on 200 meters, 1.5 megahertz, which was pretty interesting back then. In 1914, ARRL was organized by Hiram Percy Maxim to relay messages that were typically 25 miles. Hiram Percy Maxim, he was the guy, on the left, on the right bottom corner of the thing, and he was actually a machine gun. He invented several kinds of machine guns for the war efforts. So he was a technology guy, but he was a mechanical engineer. So the two, radio and mechanical things went together very well back in those days. And QST magazine was founded in 1915, and it still exists today. I'm a life member of ARRL, so I get it whether I need it or not. And you can see the simple circuits of a little Audion circuit and a lead of forest on top, and you have the guy on the bottom has got several batteries in series to generate enough plate voltage. And of course, this mechanical slider thing on this homemade coil form. I mean, this is like, that was cool in the day, of course. 1915 to 1920, stations were pretty much homemade. They were still homemade, and in these days, of course, in 1915, Ray Kellogg invented the loudspeaker, which you didn't see in ham shacks back then too much because hams didn't like them because they didn't work very well, and they were expensive and hard to get. In 1915, Carson applied for a patent for single sideband suppressed carrier. In 1916, there were stations working 750 miles across the US, and by also in 1916, later, a couple of hams transmitted messages from New York to California. So you had transcontinental stuff in the Western Hemisphere. And by 1917, there were about 6,000 hams licensed to the U.S. and probably a whole bunch more that were not licensed. It wasn't super enforced back then. I couldn't find really numbers for Europe, or I don't know. I just couldn't find any reliable numbers. But there weren't very many hams, but it was a growing thing. By 1917, of course, a lot of countries shut down ham radio because of the war, and then they started it up gradually again in 1919. And of course, Armstrong described the superheterodyne principle. Now, if you look at that, if you look at this this homemade station on the right side, it tells an interesting story. The craftsmanship was there. That box contained a high voltage transformer, and you see a knife switch that was homemade there on the right side, and a relay that was controlled by that key. But there's a spark gap on the top of the box on the left, and the tank coil. The capacitor was that Leyden jar. It was this jar with like copper foil on both sides of it to get that tank circuit to resonate. That was built on looks like a homemade wooden coil form. The interesting thing is electric lights were around in the late teens, and that little light bulb that you see with a pickup coil, that was for tuning, because meters were pretty expensive and hard to get back then. And they used this pickup coil and light bulb to tune for maximum resonance at the operating frequency. So it was different. I mean, it was still homemade stuff. Early 20s, 1920 to 26, you had some commercial gear. The stuff looked crude. You didn't have too many loudspeakers at that point yet. You had some Carson described FM. Patents were granted for single sideband, and crystal oscillators started to come into the picture. By 1924, hams received new bands at 80, 40, 20, and 5 meters, and spark transmission was prohibited on these new bands. That was like the beginning of the end for spark. If you don't understand what happened back then, I was not around back then, but I did read about this. There was wars between CW and Spark people. Like the Spark people wanted to keep Spark, and the CW people wanted to get rid of it. And eventually, by 26, they did get rid of it. It was just too broad-banded, wasn't efficient, and so on and so forth. In 1925, the IARU was founded, and this is today. It's run by a ham who's an attorney in Canada. He shows up in Geneva constantly to all these works and things, and I see these characters there. Also in 1926, Yagi and Uda invented the beam antenna. They were experimenting with this half-wave dipole, and they noticed that as they moved another thing that was approximately half-wave near this, kind of nothing would happen for a while until you got it kind of close, and then this chaotic event would happen. And this bidirectional pattern that the antenna had, that the dipole antenna had, all of a sudden went away, and it became a beam in one direction for the most part. And so that was pretty interesting. But if you see the equipment on the right, it's commercial, but it was mixed with a lot of homemade stuff. You see a few meters; they were hard to get. They were handmade, and even the commercial stuff was handmade back then. Now, in the late 20s, you had a lot more loudspeakers, a lot more commercial-looking stuff. The 10-meter band was open to amateurs. The Convention Radiotelegraphique allocated frequency bands to different services by service. So they had maritime service, fixed service, amateur, experimental. So the idea of spectrum engineering came about back in that period, which is really important. And Canada, by the way, does a really good job of it. CRC, Communications Research Center in Ottawa, is like the lab that does a lot of this work for us, for the Western Hemisphere. Almost nobody in the Western Hemisphere does it, but Canada does it. In 1928, the transmitting range of ham stations increased. They worked DX, as you know, this is the international sport. So they had to have international call signs, prefixes, and so on. In 1929, the screen grids were introduced. So you had tetrodes, and then pentodes and beam power tubes came about a year later. And in 1930, QST magazine announced 20-meter phone authorization. Phone is, of course, the abbreviation for radio telephone, which meant AM back then. But sometimes you'll see hams calling it phone or CW, and it's still like a vestige of that's where it came from. And you'll see a little more sophistication in the pictures of the stations on the right. And in the 30s, through the 30s, broadcasting was like the big deal. The union, the Telegraph Union, decided to combine the International Telegraph Convention of 1865 and the Convention Radiotelegraphique of 1905 to form the ITU, and which exists today, and it's a body of the UN, like we were discussing previously. 1934, there was a huge meeting of these guys, and they created these communication acts, country by country, which set forth amateur licensing and formalized a lot of the stuff that was kind of loosely regulated before. By 1933, of course, there were about 1,200 companies producing radios of some kind around the world. In 1935, Russ Hall described tropospheric refraction for the 5-meter band, which explained why certain signals might go beyond the line of sight range, which is kind of interesting in itself in the day. In 1936, Edwin Armstrong wrote his classic paper on FM. And of course, in 1938, amateurs lost the exclusive use of 40 meters to be shared with shortwave broadcasters. Now, there's still some in there. I still hear some shortwave broadcasters. 7205 RFE is on there. I can hear them every now and then. They'll come up around 4 p.m. Now, on the right-hand side, you see it's looking more and more commercial, the gear. Even the beginner's grade stuff looked better and more cool. The guy on the right, top right, that's his ham station. You see that receiver? I don't know what kind of receiver it is, but that's a commercial receiver, and it's good stuff. He actually was a commercial broadcaster, and that is his ham station. So there's much more sophistication to the ham equipment of the time, but it still looked a little bit, it was crude by today's standard, but it was cool compared to 20 years before. The complication of the war caused a lot of things to mess up in ham radio, including that many countries shut it off. But World War II accelerated the development of wireless technology. I mean, look at this stuff. I mean, this is really a leap ahead from the previous decade. In 1941, when the armed services needed components and equipment, Allied militaries asked hams to donate stuff, and they were flooded with whatever they needed. Hams actually, in those days, they actually built stuff for the military. They just donated their time, built equipment for these guys. Everybody was really engaged. After VJ Day in 1945, hams were gradually given authorization to get back on the air. And of course, the late 40s, what happened is this made available all this surplus equipment, which, this stuff was everywhere. That signal generator you see on the top middle, that I had one of those. I bought it at Aero Electronics, where in South Michigan Avenue in Chicago, and where you give the guy at the front desk, you give him $10 back then in like 1968, 69, and he gives you a wheelbarrow, and you can put whatever fits in that wheelbarrow, you can take home from whatever pile of huge junk they had. As long as you just take from the right pile, you're okay. So 1945 onwards, Allied Radio Lafayette. Allied Radio was at 100 Northwestern Avenue in Chicago. I used to go there. Got my first novice transmitter there. Bernstein Appleby in New York. You had Newark. I mean, you had all these companies making gear for the ham. Surplus gear was around. It was everywhere. And interesting thing, coax cable. Hams started using coax cable because before that, the availability of surplus coax cable, hams used to have to make the open wire feeders. You'd make these things out of wood. Now, the nice thing about open wire feeders is that 3 to 30 megahertz in HF frequencies, they were very low loss, much lower than coax cable. But as you know, if you ran those things, you couldn't bury the stuff. You couldn't run it next to the house. You couldn't run it near a tree. You couldn't run it definitely near metal. It would, of course, not work anymore. So coax cable, while it had more loss, you could bury it, you could run it anywhere you wanted, and it was really good. 1948, Shockley invented the transistor with Bardeen and company at Bell Labs. Why did they invent the transistor? Because at Bell Labs, in those days, vacuum tube amplifiers to transmit telephone calls coast to coast in Canada and the US were just blowing out all the time. Vacuum tubes weren't reliable. So they kept on this solid state project until they had the transistor. And you'll see, on the right-hand side, all this gear was available by the pound. We would buy it and we would cannibalize it for tube sockets, tubes, capacitors, resistors, all kinds of stuff. We could make transmitters, little mini receivers, stuff that drifted around like crazy, but we could get on the air with it. The decade of the 50s. Now this stuff, this sideband was the deal. And that thing on the bottom left was a 200V. And a friend of mine and I, Steve Dowks, who worked at Motorola at the time, VGI, WA9 VGI, and I restored one of those suckers. This used phasing single sideband, which didn't have a filter. It just used 2 vacuum tubes that did the Hilbert transform that gave you the ability to generate single sideband, getting rid of the other sideband in the carrier. Now, that's how today's DSP sideband radios work. But back in the day, these things weren't very stable. So Collins Radio Company and Helicrafters opted to use a balanced modulator and a filter, which became the order of the day for single sideband generation for a good 25, 30 years. Central Electronics, Helicrafters, they all made this stuff. 1957, there was contacts between mainland US and Hawaii. 1958, Class D citizens band service was opened up to many amateurs, it got rid of amateurs in the US and other countries, so they lost the privileges to use 11 meters, so it became citizens band. And now you see on the right-hand side, this stuff, the XX111, and there's a Heathkit Apache and a few other things I remember. Those become, by 1970s, that's the stuff that we were buying as young hams because, the guys who could afford this all moved on to Collins S-lines and stuff. In the 60s, you had solid state receivers just coming in. You had no solid state transmitters to speak of. There were some, but not widely available to the amateur. Now that little thing on the bottom, you see, bottom left, that was a Night-Kit T60. That was my novice transmitter. You had a lot of Oscar satellites were launched. You had a lot of navigation satellites. You had a lot of vacuum tube final amplifier type radios, but the receivers began to use solid state. End of the 60s, you had slow scan TV, and as you go around, the pinnacle of coolness of the 60s was that Collins S line on the bottom right hand corner. 70s, man, this was like packet and repeaters, and the metric system became more adopted. We started using kilometers and kilograms and things more, and megacycles, which we used to use in kilocycles, became replaced with megahertz and kilohertz. And Of course, there's still some hams that talk about, 5 kc FM deviation. That's what they're referring to. Ham repeaters were deployed like crazy. Chicago, where I grew up, was land of Motorola, so we had access to cheap surplus junk that we could turn into repeaters and transceivers, and there were FM portables. There was all kinds of stuff. Packet, that's a guy on the bottom left. He was in Montreal, and he was using these the first computers to generate packet signals. And you see the complement of the equipment. The Clegg FM27B, by the way, I had one of those things. And I had, as well as the HT220 that you see. But the FM27B was horrible. I mean, it was synthesizer noise all over the place. It was intermod on the receiver. The stuff was pretty primitive compared to the relatively deluxe stuff that we have today. The 80s decade was really digital, solid state. These were radios with computers in them. In other words, the computers control the radio. They weren't the radio. Today, they are the radio. It's a very different thing. The computer part was the synthesizer, the readout, a little bit of DSP stuff, but not much. That came in the 90s. ASCII computer code was authorized. We were all interested in AmTOR. I ran AmTOR and RTTY back then, and there was a little bit of spread spectrum, but only at researchers and real boring kind of hams like us used to do that kind of experimentation. The WARC bands came about. The World Administrative Radio Conference was what it was called. It was changed. The A was dropped. It's neither administrative nor a conference, so people were sort of puzzled by this. So we got 30 meters, 12 meters, and 17 meters, as well as 902 megahertz. These are some interesting little mini microbands, I guess. And in 1988, a very important thing happened. So GMDSS, this global maritime distress satellite service, was established. And I mean, this was pretty much, it started the beginning of the end for Morse code in practical everyday use commercially. On the right hand, you see, you go around from the top, you had a 751 AICOM. I had one of those. There's a Collins KWM380. I had one of those too. Ham radio was a priority. So I had a lot of gear. You see a lot of packet using IBM PCs, and they're screaming fast 5.8 megahertz processors. And all the way around to the right, all the way around clockwise, you see this girl running a packet station. But what's really funny about that is there's an R390 right above her head, which Collins made for the military. It was a very, you can still see these today. It was still a really good receiver. The decade of the 90s was DSP filtering. You had the Coast Guard stopped their monitoring of 500 kHz distress frequencies. And then by 99, most commercial ship-to-shore CW stations closed after like decades of service. And throughout the 90s, there were all kinds of, the information theorists developed a lot of interesting digital modulation and coding schemes like Domino EX and PSK31 and Contestia, Olivia, all this JT65, Joe Taylor, Thor, and all this stuff. And by the year 2000, there really weren't any countries, not many at all around the world, that required Morse code proficiency to get a ham license. As you go around clockwise here, you can see the equipment of the day. The 775 DSP on the top, that was slick. That thing weighed about 50 pounds. I had one. And there were a lot of other stuff. But as you go around clockwise, you end up this German ham on the left bottom. Like this is a real 90s thing. She's got like the minimal ham station. You got an amp, a transceiver, and a rotor control. And that was it. That became the ham station of the 90s in a lot of cases, the minimalist station. 2000 to present, over the past 20 years, it's just SDR. The digital modulation techniques, FT8, Reverse beacons were developed by a friend of mine, actually. That's Nick Sinanis, F5VIH. He's actually one of the heads of the Space Communication Division at ITU in Geneva, and he lives in just across in France. But reverse beacons are cool. It's a CW thing. You can look up your call sign and see which countries are hearing you. SDR became available to hams, and man, they're really cheap. You can get a not very good but workable SDR for $100 these days, or even less. And of course, digital voice. You had D-Star, there's DMR, there's all kinds of other stuff, and digital signaling systems. And you can see it's all about flex. It's all about the Elecraft Kilo 4s, and just Anons and what have you. That's been the score for just an improving steadily over the past 20 years. Now, it's the future. I mean, the future is pretty much, what you make of it. I don't know what you guys think, but I think that ham radio is still going to be a practical medium that allows researchers and people to experiment with stuff and try things out. But one thing I noticed, in putting this thing together and reviewing it and so on, and throughout I've been a ham for 55 years already, which it doesn't seem possible. What I noticed is that today you've never had so many options of different stuff to participate in with amateur radio. You can build things, but not just CW and sideband or CW and AM. I mean, you can build whatever you want. You can build SDRs. You can build things with the Raspberry Pis and so on. And it's pretty much going to be what you make it. I'd like to hear from you guys as to what you think next time we meet in person. But anyway, this is exactly 45 minutes. So this is really all I have for you guys. So thanks.
Well, Mark, I want to say thank you very much. It was a really great kind of whirlwind tour of the history of amateur radio. And I wonder if people have some questions or observations that they'd like to make.
I have a question. Way back at the beginning, you showed the schematics for the radio that was included on the Titanic, and I think you said it was 5 kilowatts. Is that the case? That seems like an awful lot of power. Surely more than was strictly necessary to send CW across the Atlantic, no?
No. Back then, you'd had really bad receivers. And you see, if you ever study strategy in business, I really enjoyed studying strategy in business school. I mean, I'm not just an engineer, but the same forces-based strategy, like scenario planning, is really where it's at. And the same forces are at work today. The problem is, in a phone. Okay, so you have smartphones, and the problems today is, where do you put the battery? Where do you put the antenna? Mm-hmm. Back in the shipboard days, the question was, okay, does my generator fill up the entire room, or does it fill up in half of the room? What do I do with the antenna? Is it like this huge thing that, where do I put it? How do I make it efficient? The problems are the same. It's just that we've gotten better at dealing with them. But 5 kilowatts, I mean, that's what you needed back then.
I was quite surprised at how late the invention of the loudspeaker came in your presentation, after there'd already been quite a lot of other audio stuff. Before loudspeakers, I mean, what are you talking about? Headsets, but I mean, they're still loudspeakers, aren't they? What was going on there?
Yeah, they were headsets. But the problem is they were all handmade, and so they were wound, by hand, and they weren't very efficient. They amplified the sound by a paper cone, and that was actually its little amplification system to focus the sound in one direction. And it was yeah. Now, what I learned at working at Bell Labs is we were one of the most vertically integrated companies. I mean, if you remember how vertically integrated RIM was with, making the chipsets and doing the radio stack, and that was one of the things I did there is I integrated the radio stack stuff in Hugh Hines Group. And instead of letting the people in the UK who were selling us the chips sell us the radio stack, this way we could fix our own problems. Western Electric actually had a coal mine. They had a train system, a rail system. They would mine the coal, they'd ship it to Western Electric in Cicero, Illinois, crush the coal and make carbon microphones out of it. And I mean, this was within our lifetime. It was still going on.
Mark, you showed a picture of Hams starting to use Audions in the late teens or early 20s. So were they using them as simple diodes for demodulation, or were they actually already starting to use regenerative detection?
Regenerative detection came at a similar time because they discovered they could make them oscillate, and they were using them as transmitters and using them as also simple, RF amplifiers and the so-called TRF receiver, the tuned radio frequency receiver. Right. But yeah, they started with regeneration once they discovered you could put some of the signal back into the input.
Yeah,
not quite make the whole thing fly in the wrong kind of way, but it would actually detect the signals, and you could detect like 1 microvolt signals with those simple receivers. Minus 110 dBm. I mean, that was okay.
Have you ever had a regen? I haven't had a regen receiver.
Oh yeah, I've built them and out of tubes and transistors, and I have a whole bag of MPF 102s. If anybody wants some of them, you can build yourself a regen receiver. They're not hard to build. They're pretty broad though. They don't have the selectivity.
Pretty good QRP transmitters too.
Oh yeah. So I hope you guys learn something. I learned a lot from putting this thing together, and I have a better appreciation of the strategic forces that we use today, seeing that the ITU regulations and spectrum engineering wasn't just something that was thought up in the past 30, 40 years. It has its roots back into 1905. And what's going to happen in the next 100 years, who knows? But hams will play a big part of it. And I think Vic had mentioned I was involved in the invention of a lot of the stuff in the cellular systems used globally now. And I can tell you, if hams were not involved, I didn't really realize this at the time, but there was a ton of us involved who were hams that worked on the standards for cellular. And I don't think cellular would work the way it works today if hams weren't involved, because it always seemed to be the hams who came up with the solution to the really weird problems.
Okay, wonderful. It certainly piqued my interest about single sideband invention. A gap in my knowledge. I didn't know it went back that long. Gord, VE3EOS, has tutored me on early single sideband, but my goodness, I didn't realize that it went that far back. So that is on my reading list. I'm going to get back to that and see how that was all developed. Well, thank you very much. Thank you very much, Mark. Really enjoyed it. We all enjoyed it. It was super. Anytime you have interesting presentation, you think it would fit, we'd love to have it come in. Okay, Roger put up his hand. Do you have a question, Roger?
Where's the button? No, that was the applause.
Okay.
That was
applause. See, I don't, okay. It's a golden handshake there, I think it was. Thank you so much. So,